Hi and welcome back to the lab. And today here on the bench we have a Kenwood TM-742, which is a tri-bender, very nice vintage radio, and the radio won't fire up. So let's have a look and let's see if we can help. Okay, and here's our TM-742, and so we have the external panel, and you see that we have the extension wire connected here to the radio, which is always a little bit critical, because very often those cables making trouble. Anyway, so let's see what we can find. So first of all, let us connect the radio to the power supply, and what we see is already that we have a standby current of 35 milliamps, which is quite good, because that is what was expected. Good indication. Now let's try to fire it up. Oh, okay, it is working. It is working right from the beginning, so no problem whatsoever. Okay, the fault description was no firing up, but okay, it is definitely working. And you see we have our three models inside, 2 meter, 70 centimeter, and here 1.2 gigahertz. Yeah, winner. Okay, not sure what's going on here. Okay, in this radio it is known that we have faulty capacitors. And if those capacitors lowering their capacitance, then the reset circuit start making trouble. So maybe it is something like that we have already a faulty capacitor around our reset circuit. But now, in this moment, the capacitor is strong enough to fire the radio up, to give the reset pulse which is needed to reset our processor. So there is no other way than to take it apart and check if we find something around our reset circuit. Okay, as you can see, I have already taken here our front panel apart, and I'm already probing here at our reset circuit, because that was the first interest. So, and here you see the result of our reset circuit. So when we connect power to the radio, so that means connecting the radio to our power supply, the reset process directly starts. And that is what you see here. So our blue line here, so that is the 5 volt, which is coming out our voltage regulator, right? And down below, so that is what is coming out of our reset pin. And that means while we have already our voltage present at our microprocessor, we have our reset circuit holding the processor for 200 milliseconds low. So that is exactly what the specs are telling us. So we expecting with the reset capacitor a delay of 100 milliseconds, and you may see, can you see it? I don't know. So we have 50 milliseconds per division, and you see that we have here 2 divisions delay, which makes it 100 milliseconds. So that is telling me that you know, the reset circuit itself is working. But we have some other funny behavior here of our radio. So first of all, I told you that when I tested it first, when we plug it here to the power supply, that you know, 35 milliamps is more or less fine for the radio, for the radio's standby current. So that is no problem. And when I try to fire it up, you see that it is coming up without any problems. And we have then, you know, a receive current draw of approximately 1 amp. So let me call it that way. So that is fine as well. But when you go back here in the video, when I tested it first time, when I was surprised that it is firing up, I also was pushing here this pots here. So we have a third function here with these regulators, so we can push it, and when we push it, we can normally switch over to another band where we want to transmit. So you see, now we have here our transmit identification. So you see PTT is on 1.2 gig, and normally you would switch it over by simply pushing here the pot, and you hear that there is a tone in the background, and that should be here our 70 centimeter, where I want to get my signal or my PTT over, and you see it doesn't work. And when we tested it first, these both were working. Go back in the video and you see it, but here the 2 meter one, so you do not even hear a tone. So that is already funny enough, because that, you know, is definitely not normal. But on the other hand, let me switch it off once again. So here, that is here our voltage regulator, so 5-volt voltage regulator, and our reset circuit. So this component here do both. And we have here on, let me see, on the other side here, we have, ooh, what is this? No focus. Okay, this both capacitors here are the only one here in this radio, and this is here filtering, if you like, our 5-volt supply voltage, which is coming out of our regulator. And here we have a second capacitor, and that is the delay capacitor, making our 100 milliseconds delay for reset. And yeah, from the first look, these both components do not really look like that we have something leaking here, which we often have seen. And if those capacitors are leaking for a very long time, so we see destroyed traces here on the PCB, and more we see this more on the model 741. So the model TM-741 is really suffering much more from this problem. The TM-742 is the improved version of the 741, of course, and that model here is not so much suffering from it, but still it is suffering. So normally this both components needs to get replaced to get it under control. But you know, having this symptom that we cannot really switch over the PTT to another band, so that is something different, and it looks a little bit that we have you know, interruption here on the PCB. But the question is, if we have interruption on a layer here on the board, the question is, why do we have these interruptions? So normally that happens if we have leaking electrolytic capacitors, but since we only have two here on our board, I really wonder if maybe underneath we have something which shows a leaking component. So maybe we really have to take it, you know, away here from the board to get a better impression what's really going on. And I found a second symptom, which is very funny. So we already discussed that we normally have 35 milliamps as a standby current. So for the moment, you see, it is jumping here a little bit back and forth, and I have found that we suddenly had something around 150 milliamp standby current. That is a standby current. And when I saw 100, it was approximately 150 milliamp standby current, I recognized that I was not able to firing up the radio, and that is exactly the symptom what the old man was telling me. So that he tried you know, to fire the radio up, but it doesn't work. And I have not seen it, because with 35 milliamps I can always fire it up with some, of course, funny behavior. But you know, now it is not so significant the changes here, but I've also seen that it is moving quite more up and down, which makes me wonder what is causing it. Is there maybe you know, a capacitor which is sometimes leaking a little bit and makes or is creating the problem of not firing up? Well, and we can of course not say if it is you know, here a capacitor on our front panel board, or is it something here in the radio itself, because the main CPU is here in the radio, and we have here only on you know, the front panel, I mean, there is as well a controller, so that is what we see down here. So that is a controller. So and this controller is working together with the main CPU here in the radio. So you know, that is all a little bit weird, and yeah, I do not really know what's going on here. Okay, so what we can test else is the traffic between the main processor here in the radio and our front end processor, because this both processors are always talking to each other, and that is something we should be able to see even if the radio is completely switched off. So it is only running in standby, but because we have here a very old radio, we have, while it is in standby, we see a permanent data communication on both serial lines, transmit and receive. Newer radios have a much lower standby current, and you wouldn't see it in standby. But this is an old radio, and when I go here, so I have here, you know, the RX and here the TX line. So two data wires, serial data wires, and that is something we should see on our scope. And that is something you see here. So that is the standby communication, and you see when I change here from TX over to RX, you see that it is changing, and you see that the data is flipping a little bit left and right, so that is different bits which are changing here. You can see it, and that is telling me that there is a permanent data transfer between the main processor and here our front end processor. So on both lines I have data communication. And now when I switch the radio on, so you see it, here we have it, radio is on, and you see when I now change here, oops, I'm just slipped away here, when I just only change, for instance, volume, so that is what I'm doing here, I'm changing the volume level, so you see the data communication between both processors, and I can really see it on both serial data lines. So you can see the data communication, so that is given, so we do not have you know, a problem with our data communication. Okay, so we are here on our schematic, and that is our IC2, so that is what we already talked about. So that is our 5-volt DC power supply for the front end, and here we have our reset pulse, which sits on 4.2 volt. At the input we should have 11 volt. I do not really can read it very good because it is a bad copy. It's a very old radio, and here on the reset capacitor we should read 5.9. So that is something we can test in a second, but additional to that, we have seen that our band select B does not react in any way. So you see here, so we have of course our two pots, that is for sure, but additional to that, we have this switch here, our push switch, and we have recognized that this switch does not react, so we do not hear a beep, and even, I don't know if it was the A or the C one, does not switch over the PTT to the other band. And when we follow along here, our switch, right, which is basically a voltage which we switch to ground, as you can you see it? No, can't see it. So when we press it here, so it is going to ground, right? So that means, why does this switch not work? And when we follow here the line, or positive line, so we come over to, let me see that you all can see it here, to CP5, which is here a resistor network, and this is nothing else, delivering positive voltage of 5 volt to one side here of our resistor board, and then giving it on a direct way to, as you can see, the processor, which is here, right? And that means this here is nothing but pull-up resistors, and here are the lines coming from our switch. When we now switch the switch to ground, which we do, then we pull the input of the processor to 0, to low, which then will give a reaction, and that is not working. And I really wonder why it is. Is it a broken switch? Maybe. So is that not working, or is something wrong here with our 5 volt, or what is it? So that is something we really need to investigate. Alright, so what we can do now is checking all the voltages here at our regulator and reset the component, and then we can check here, of course. So we have, let me see where it is. So all these regulators has, as we have seen, a push button, and the push button is here, this both contacts, and we can check, because we have seen at our resistor bar, which are working as pull-up, so we should see our positive 5 volt at our switch, and when we push the switch, then we should go, we should see the signal go to low. So that is what we can test. But now we start first here with our regulator, and we go step by step. Okay, so we start with pin 1, which should be around 7 volt, 7.8, so that is fine. Pin 2, so that is the delay pin, and that should sit on 5.9 according to my schematic, and it is sitting on 5.4, which might be a little bit too low, especially when we are talking about the delay capacitor. Could it be that this capacitor is a little bit leaky? Okay, so the third one should be the reset pulse, which should minimum sit on 4. I can't read it. Is it 4.2 or 4.7? Well, maybe it is a little bit too low. I'm not entirely sure. And what we can see here, so that is our regulated 5 volt, which is obviously fine with no problem. But yeah, we really should check, you know, the delay capacitor, which is 1 microfarad. So that is a tantalum capacitor. Yeah, let me check that later. Now let me go over to our push buttons, and that is the first one, which is okay, so we need of course to switch our radio on. So we have tested now in standby. Now we switch the radio are on, and it is switched on. Okay. Now I go to the first push button contact, and yes, so we see our 5 volt here, which is right. And when we press, I now press a button, and it goes down to 0, which is fine, no problem. Now I go over to the middle, so that is the one where we had no reaction. I'm already on the contact, and you see there is no voltage, and that is wrong. So let me go to the last one, which is here, and you see that is again sitting on 5 volt. When I press it, yes, it goes down to 0, and you can hear the tone, right? Going back to our middle pot, so that is the 2 meter adjustment here, and there is no 5 volt. So there is already something wrong. So is it an interrupted trace here on our PCB? I don't know. So we spoke about already the CP5 bar, that is delivering or is our pull-up resistor, if you like, and that means so we have these 3 which are going to our push buttons, and of course without having pushed our button we should see here our 5 volt. So let me check that here on the radio. Oh look, before we go ahead, look here, we have this 150-160 milliamps, which I've already told you. And now when we go down here to our unit, so it is off, right? And now when I try to start the unit, so you see absolutely nothing is happening. So that is odd. So that is what I've told you, and I do not know where this 152 milliamps are coming from, but I know that something of course is wrong, and that is now, yes, where we can't switch it in, on, fire up, whatever. It doesn't work at all. Well, you know, I really was searching for the high current which we saw, where we were not able to start up the radio. So, well, now I really have to say, I don't know what really has happened here. So for the moment you see that our current draw is just fine, but really look at this. What the hell is going on here on our PCB? So somebody was in already. I mean, we have here a modification which has been done. So for a modem, 9.6K modem, I believe, but is that here the cause or the root cause of our problem? So you know, when I had the high current, I was wiggling here. Look here. So what is this here? What is this? Have a look. So I really don't know what was going on here. So you see, we have here a broken piece of solder. So you can obviously see this here, which is of course a problem. And then the solder point itself is a problem. And then look here, we have some other odd solder points here. And look here, so that is really, that is, I don't know, can you see this? So I mean, yes, we have here a solder post like this one here. Hope you can see it. But you see a solder blob here from this is going over to two traces here. And wow, I don't know if that is something what is causing our problem. So what I can tell you is, when we had our 150 milliamps and the radio was not starting, when I then was going over here a little bit, like so, okay, then suddenly the current dropped down to 35 milliamps and I was able to start the radio again. So, wow, you know, that is going to become a rabbit hole. I don't believe it. So as you can see, I've tried to clean up here a little bit this area, and you see now here the post is okay, so it's not any longer going over the traces, and everything looks now much better. But finally it is not clear that this here will solve our problem. I mean, it was maybe part of the problem, but yeah, I really don't know what has been done here to the radio. But well, modifications in any kind are always difficult, and I believe this was from finally the modification. I think I cannot tell by 100%, but I believe. But there are still other odd behavior, and the problem is the radio really is quite old. It is really quite old. We do not get any spare parts for the radio, and we still have the interruption of or on our front panel board, so this push button, which may lead to the conclusion that there must be something happening inside, you know, the layer. I really don't know, but everything is quite odd. Okay, so besides the fact what we have seen so far, I still have the impression that with the 150 milliamp thing, that there is something wrong here on our controller unit. So the 150 milliamps are still there, even if I pull here our connection cable here. And by the way, you see that I have swapped out the extended cable just for convenience here on the repair. So I have only this short one here between, which is fine. But still, even if I take it away, we have this 150 milliamp sink when it is there, so that is only intermittent. So, well, therefore we need to dive a little bit more here in our, yeah, it is here the, I don't know, extended front end or whatever. So that is our, so literally we have two boards here, and both are, yeah, the controller somehow. And well, I still believe that there is something wrong, so therefore we need to take it a little bit more apart, and let's see what's going on here. And then, as we already has discussed, we have the issue here with the intermitted connection here for our middle pin here, or switch. So, you know, it is already a rabbit hole, but yeah, let's see if we can do something. But we always should have in mind this is a very old radio, and finally, really, we do not get any from this spare parts here, so it is totally end of service. Anyways, let's dive a little bit deeper here into that issue, and let's see if we can find a little bit more. So first of all, you see here this modification. This is this data cable, which has been used in the past for packet radio, I believe, and that is no longer needed. So we simply remove this modification in order to get everything away which could be potentially harmful for here the function of our radio. Okay, so as you can see, I have taken it apart. So we have here both parts of our controller or control board, and interestingly, we have here a capacitor, an SMD capacitor. It is marked as C54, but on my schematic it is not mentioned. But interestingly, that seems to be a leaking capacitor. Okay, so look here. Here we have our SMD capacitor in question, and you see it is marked as C54, but it is not on the schematic, which is a little bit odd. So, and look here, so you see the contacts, and so something is here on the board, and that is most likely acid here from this capacitor. So let me see where we can see it best. Let's try to get it in best. And here you may see, maybe I can, so let's see. Okay, maybe that would work. So what you may already see is that we have here, yeah, so it's directly going off. So, and you see that this capacitor is definitely leaking. So we have to take it away here from the board. 16 volt, 4.7 microfarad. We do not really see what's underneath, but it might be the case that we have so much acid underneath that the traces which are going underneath are maybe already in trouble. Okay, so first it is a good idea to get it off here, so that will be our first step. And I put, as always, a little bit flux here to the component, and then yeah, let's try to get it out. Of course, first we try to get here some fresh solder to the joints, which I believe will be already a little bit difficult, simply because we have already a lot of acid here on the board, which will definitely make it a little bit more complicated. But okay, let's try. What we can do here, that is what I thought. So I literally cannot get contact here, or cannot really get in touch here with the solder joint. Now it's getting a little bit better, but not perfect. Anyways, let's try on the other side. So you even cannot melt, in most cases, the old the old solder. So that for its own is always a pain here. Yeah, you may see how difficult it is, and you see all the brown liquid which is coming out, which is another clear hint that we have here, yeah, we have really a problem here on the board. Okay, we always, of course, try here our best to get the component off, but sometimes, you know, that is really not easy. But okay, so we were lucky. As you see, our pre-work was efficient enough that we were able to get it off here. Now we have to clean it, of course. Okay, so I have cleaned here the board, and what you can see, so we have our pads, no problem, that is good. And well, there is only here, that might be a problem, so we have to check that, because you may see that some acid already runs here into this through. And maybe that is an issue. We have to check that. But other than that, we were lucky. So there is no interruption so far. So here, that is, we have to clean it. Everything else is fine. Okay, so we have cleaned it, and what you can see here, there is already some copper eaten away from the acid, so you really see what the acid can do. So I've tried to clean here everything a little bit, that you know, we can use it in the future. So therefore now we need to cover here a little bit the open copper here, that it is nice. Yeah, so that will be the next step. So let's cover it here a little bit. Let me see. It is already too much, but better to have here a little bit too much than finally too less. Therefore that is already good, and let's see that we can dry it out a little bit. So now we need to harden it out here with some UV light. That was not my UV light. Where is my UV light? Here it is. That is my UV light, and of course it will now take a little while. Okay, so we have covered the area, and here we have to clean it just a little bit, because here we put our new capacitor on, and so yeah, looks quite nice, everything. Yeah, and here you see we have our 4.7 microfarad tantalum capacitors. So that is a type I'm gonna put in. So that is all is 16 volt also. So that is a perfect fit. Okay, so let's check here. So that is, yes, that is a perfect fit. And that means this capacitor has to go down here. Very nice. And as always, we have here a little bit flux here. And now let's prepare here our solder joint. Okay. Okay, that looks perfect. So I've covered here the rest with solder, and that means that everything should be absolutely fine here. So now let's put our component down. Excellent, here we have it, and now only the other side, and we are ready to go. And of course I have flipped it over here, and now I can solder here the second side, and again I try to cover here a little bit the traces in order to cover them with a little bit tin, and I think it is just fine as it is. Well, I really don't know if this capacitor will solve our problem, but anyways, the old capacitor had to go, so no problem. Okay, after changing here our SMD capacitor, our 150 milliamp problem didn't come up again, but up to now that doesn't mean anything, because it is a hidden and complicated problem. It is intermittent, and therefore it is not subsequently clear that our new capacitor is solving the problem. But anyways, I've tested here all electrolytic capacitors on ESR, and all are fine. I cannot find any problem. So I have to put here our controller, our two controller boards at least, back into its metal frame, because here the components are getting very hot, and I need the radio running, because we have to work here on our front panel as well, because we have still the problem here with our knobs. So therefore first I put this back into the frame. But what I wanted to show you, so that is our little SMD cap which was leaking, and which we have taken off from our controller board. And interesting is one test result. Okay, let me try to get it on the cam here. So testing this capacitor for ESR, look what we get, 1590. So that means more than 1.5 kilo ohm, and you see the indication is showing bad. So that capacitor is definitely dead. Alright, so our frame is back together, and I'm able to let the radio run. And we already discussed here about the fact that our pot in the middle does not react when I want to switch the PTT to the middle is a 2 meter band. I do have a tone, as you hopefully can hear, when I press here the right one, and when I press the left one we have also a tone, but no tone, no beep here on the middle. And additional to that, even I have here, you know, a beep, I cannot switch the PTT, which you see here, over to the 70 centimeter band, whereby here our 2 meter band does not react in any way. So that is what we want to check. And what we already found is that this component down here, this here, so that is our resistor bar, which delivers the high potential to our processor. And when I press the bottom here, which switches simply to ground, then this is our pull-up resistor, and I can bring a low to the processor, whereby if we do nothing, it is always a high signal present at our processor input, right? So that is now a little bit difficult to demonstrate, but what you see on the voltmeter is 4.9 volt, and that is voltage at our resistor, which is delivering our high potential to the processor. And when I now press, can you see it? I don't know. It is a little bit tricky here. But when I press here the right button to switch our PTT to the 70 centimeter band, watch here our voltage. So you see the voltage is collapsing to 0, which means that I'm able to deliver, while I'm pushing the button, the low level to our processor, right? And that is working quite nice. It is working on both, but it is not working here on our 2 meter selector, if you like. But when I go down here to the test point, so that is here the test point at our resistor, and you see again that we have our 5 volt. But now when I press here the button, you see I'm not able to get a low level to our processor input. And the problem is, I mean we have an interruption somewhere. I don't know why, and I do not know where, but we have an interruption from our resistor bar to our connector. That is for sure. The issue is, I do not really know if we have only our 5 volt at the resistor, or do we have it at our processor as well. Okay, so let me show you what I mean. So that is our front panel processor, and down here, here's our switch. No, here's our pot switch section. And yeah, let me zoom in that you better see what I'm saying. So let's do it this way. So first of all, once again, we have already looked at this situation. So here, so these are our pots for squelch and volume on 2 meter, and we have here our switch where we can set the PTT to the 2 meter channel, if you like. Okay, and we have here our resistor bar as already described, or CP5. That is what I've shown you, and I've tested, or let me go over first here to our processor. So you see the plus 5 volt which we get over our resistors to our processor delivers permanent high level to our processor. Okay, so now you see that we have here always a connection down to our, and here you can see it, here are our lines going here to our switch. Okay, and you see that the switch is connected at one end to ground. Okay, now what I have shown you already, when I test here and press the button, then you see that the 5 volt disappears, and that means we are able to give a low level to our processor. But here at the middle we do not really get you know, our 5 volt, or no, that's wrong. So we can test our 5 volt, so that is given, but when we press our button, then we are not able to pull our 5 volt to ground. So the question is now, I mean, the button, the switch here itself is good. I've tested it. Everything is fine. So the connection to ground is given. Everything is good. But what I don't know is if we have our needed high at our processor. And if not, that could mean that our processor is in an undefined position, or that it is producing some malfunctions. So that could be the reason, potentially, that we are not able to switch between, you have seen it, 70 centimeter and our 1.2 gigahertz channel, or channel or module or whatever. And well, so the question is if our 5 volt is reaching our processor. So therefore what I try is to bridge here our switch down here, right? I try to bridge this point over to our resistors, and let us try if we have bridged it, that we get our function back. Okay, so what you see here is at least our bar, and it is the right one here, and we need to put here a bridge wire to our second port here, if you like, and we try to get it over to our switch, and then let's see what it does. Alright, so I have already put some flux here to our solder point, and I need to put some fresh solder to the middle pin here, because there we need to get our wire to, right? So now we try to get the wire connected. Whoops. Okay, seems to be good. And now let's go to the other point where we need to connect it to. Yeah, and what you can see here already is our switching contact, and you see this here is ground, so very easy to see, and we need to connect our wire, which we already have here, as you may see, and that needs to go down here. Yeah, and what you see here, we have already connected our wire to the contact here, and I'm really curious now what will be the behavior now. Okay, and as you can see, our power supply is connected back to the radio, and now let's fire it up. So let's fire it up. Yeah, it is coming up, and okay, So now let's try the one we already found good. And you might hear the beep, but I'm still not able to get the PTT over. This one is working as well. And now the question is, what's about here our middle one? Ah, okay. So we have the beep, and that clearly means that the contact does something to the microprocessor, because otherwise we wouldn't hear the acknowledgement, right? So you clearly hear that now that is working, but it doesn't really work still, because there is another problem still here on the board. And there is still a very little chance that our Bose capacitors, which are known for making trouble, having a problem as well. So let me switch here the SMD electrolytic and here our little tantalum Bose. We're gonna swap out, and let's hope that that will cure the problem. And you may see here, even under the microscope, it is somewhat delicate here to get here to the contacts. So we need to take this one out, of course, and you see that to get down to the contacts is not easy, because we have here, not sure if you can see it, let me check if we can see it here somehow. Yeah, maybe so. We have here we have components, and I need to get under this little component here, which is a little capacitor, to get down here to our electrolytic SMD capacitor joint, to get it finally out. So you see, it is really critical what we need to do here. Yeah, and as you can see, we have replaced here our Bose capacitors, which I already told it so many times, are known for becoming faulty. So let's see if this now cures our problem with our front end. Not front end, front panel I mean. Okay, so everything is back for testing, and what I can say so far is that on standby I really constantly see 33 milliamps, and that seems to be really constant now. You know that we have this up and down before. I mean, before we swapped out here on our radio the capacitor, and this up and down is gone for sure. So that really makes me hope that this intermittent problem is really gone. Okay, and after replacing here our Bose capacitors as discussed, everything is back together, and I performed a reset, and now let's see what we have. Okay, so it is on the 70 centimeter, and now let's see. I mean, we have still here our bridge, right? We have still our bridge. Do you see that? I mean, it's a little green wire, but I think you can see it. It is still in, and yeah, so let's see what we have. Let's see what we have now. Let's try 2 meter, and wow, have a look, it's working. And here 1.2 gigahertz, it's working, so I can switch it as I like. So that is beautiful, isn't it? Okay, so let me put back here our PCB into the housing, and then let's do a short test on does it transmit and does it receive. Okay, so everything is back together, and let's perform a brief test. I mean, the radio didn't come in with problems on you know, transmit or receive. It was not switching on, so therefore just let's perform here a short test, and you see, yeah, everything is fine. Can I transmit? And I see, so it is set on low. I can see that we transmit with 5 watt. So that means that everything looks good, and well, radio can go back. Well, and well, okay, the last thing we need to do is to check here if the wire is fine, because maybe something is wrong here with the wire, but that is nothing we really need to do here on video. So I would say everything is fine. Still here, the modification is still in. I didn't take it out, but I have disconnected it here from the board, and so it is still in, but it is ineffective. So that is what I have done, and everything else is okay. So that means we are here at the end of this video. Thanks for watching, and catch you next time. Bye.